Hello students, today we learn the simplex method for solving the optimum solution. Why we solve the simplex method or why we use the simplex method? Suppose we want to produce a product. Different factors like workers, machine, raw materials are important for that. Now, if there are only two or three machines and workers, then we easily find by using graphical method to optimum solution. But in company there are largest number of machines, workers. Therefore, it is difficult to find the values or optimum solution by graphical method or any other method. Therefore, in that case, we use the simplex method. We convert our values in linear programming and then calculate our profit or loss for finding the values of variables x1, x2 or variables y1, y2 in that way. What is mean by optimum solution? The best possible solution to a problem with a given set of constraints. It is the solution that achieves the highest level of efficiency, effectiveness and profitability while taking into account various factors such as time, cost and quantity. We give one example on that simplex method. Suppose there is an LPP, that is linear programming problem. Maximize z equals to 5x1 plus 3x2 subject to constraints 3x1 plus 5x2 less than equals to 15, 6x1 plus 2x2 less than equals to 24, x1 x2 greater than equals to 0. What is mean by this problem or what is mean by this linear programming? This maximize z is a objective function. Objective function म्हणजे काय? Means the linear function to be optimized. Optimize means either maximize or minimize. Maximize असेल तर gains or productive time और minimize असेल तर cost. Minimize the cost and maximize असेल तर maximize the productive time. Okay, it is called objective function. Here our objective function is maximize z equals to 5x1 plus 3x2. That is maximize function. Means we want to gains or maximize the productive time of our product or profit of our product. Okay, these two are constraints. These x1 and x2 are decision variable. Means we want to find the values of x1 and x2, then we get the values of maximize z, that is we get then the value of our profit. Okay, first convert this problem into standard form. Standard form means we using, if our constraint is less than equals to type, then we use to convert standard form as a slack variables. If our constraint are greater than equals to type, then we convert it standard form by using surplus variable. Okay, big M method is also simplex method, but big M method is used in minimization type of problem. Okay, first this is maximize type of problem and our constraint are less than equals to type, therefore we add two slack variable here. Our example is that our maximize z equals to 5x1 plus 3x2 subject to the conditions 3x1 plus 5x2 less than equals to 15, 6x1 plus 2x2 less than equals to 24, x1 x2 greater than equals to 0. We convert this standard form. Here are two constraints. We want to make this equal to type of constraint. Therefore, we add two slack variable here. Here we add s1, here we add s2, and in our objective function we add 0 s1 into plus 0 s2. Why we multiply by 0? If we take some slack variable or surplus variable, our total profit or our total cost does not change by any other values. Therefore, we use here 0. Multiply by 0, our answer does not change. Therefore, we take here 0 s1 plus 0 s2. Our total profit and our total our profit or our total cost of matrix does not change. Okay, therefore s1 and s2 are slack variables. Now we want to find basic variables and non-basic variable. How to choose the basic variables and non-basic variable? put any two variables. Here are four variables, x1, x2, s1, s2, right? Therefore we want to put any two variables equals to 0. Then which variable we put equals to 0? Put these variables 0 which gives us the value of other variables. Suppose we take x1 equals to 0, x2 equals to 0, we get directly s1 equals to 15, s2 equals to 24. If we take x1, s1 equals to 0, then here we get x2 equals to 15 upon 5 means 3, and here x2 is remaining and s2 is remaining, therefore does not satisfy two constraint. If we take x2, s2 equals to 0, then here we get x1 equals to something, and here we not get x1 and s1, that is two variables are remaining. Therefore we take 0, that variable which satisfies this constraint, two constraints, and which gives the value of two variables, which gives the basic variables and non-basic variables. And how we find the variables are 0, how many variables put with 0? If there are four variables, then 4 minus number of constraints are 2, which is equals to 2. That is, we have two number of non-basic variables. If our constraints are 3, our variables are 5, then 5 minus 3, 2. Then again put two number of basic variables. If our constraints are 2, our variables are 5, then we take 5 minus 2 equals to 3. Then we put 3 variables equals to 0. Here 2 variables equals to 0. Therefore we put x1, x2 0. x1, x2 equals to 0. Therefore we easily find s1 equals to 15 and s2 equals to 24. Okay. Therefore initial basic feasible solution is given by x1 equals to 15, s2 equals to 24, and x1, x2 equals to 0. Now we construct the table. In table, CB means coefficient of basic variable, here basis variables, here CI means coefficient of all variables in the objective function, here constant, here ratio, and here we write basis element. Which are two basis elements? S1 and S2 are basis element. Now we convert basic into non-basic element and non-basis into basis. Now here write CB, coefficient of basic variable in objective function. Here basic variable are S1, S2. Then see the objective function 5x1 plus 3x2 plus 0s1 into 0s2. What is the coefficient of basic variable? 0 and 0. Therefore we write here 0. Here also we write 0. Now here write coefficient of all variables in the objective functions. x1's coefficient are 5, x2 coefficient is 3, s1's coefficient is 0, s2 coefficient is 0. Therefore we write here 5, 3, 0, 0. Now we write the other values by using constraints. Okay, first value, write here all values by using constraint. In constraint, coefficient of x1 is 3, coefficient of x2 is 5, coefficient of s1 is 0 and 1 and coefficient of s2 is 0 and constant is 15. Right here 3, 5, 1, 0 and constant is 15. Now second constraint 6 to 0, 1. 6 to s1 is not available in second constraint, therefore it is 0, 1 and the constant function is 24. Now we want all zj minus cj are greater than equals to 0. If our all zj minus cj is greater than equals to 0, then our solution is optimum. We have to find optimum solution. Okay. Then how we calculate zj minus cj? First multiply 0 into 3, 0 plus 0 into 6, 0 minus cj, that is minus 5. Again say 0 into 3 plus 0 into 6 minus 5. Next, 0 into 5 plus 0 into 2, 0 into 5, 0, 0 into 2, 0, 0 minus 3, minus 3. Again 0 into 1, 0, 0 into 0, 0, 0 minus 0, 0. In that way we find for each column Zg minus Cj. Again 0 into 0, 0, 0 into 1, 0, 0 minus 0, 0. Here all Zj minus Cj are greater than equals to 0? Not. Here not all Zj minus Cj are greater than equal to 0. Therefore our solution is not optimum for in that case. Therefore we want to find optimum solution. We want to select entering element, entering variable and leaving variable. How? First we choose the entering column or entering variable, which is called also pivotal column. The most negative number, we select the most negative number as a pivotal column. Right here, pivotal column. It is most negative number -5. Therefore we select from here which is pivotal column. Now we find the ratio. How we find the ratio? Divide constant by the pivot column. 15, divide corresponding element of pivot column 3. 15 upon 3, 5. 24, divide corresponding element of the pivot column. 24 divided by 6, it is 4. Now we select the leaving variable or departing variable, or it is also called pivot row. Which is pivot row? We select the minimum ratio as a pivot row. Therefore our pivot element is intersection of pivot row and pivot column, which is 6. Therefore we write our pivot column, our pivot row and pivot element, and also our leaving variable means pivot row element, it is S2, and entering variable is X1. Okay, therefore our pivot element is 6, our leaving variable is S2, and our entering variable is X1. Okay, which is X1. Therefore we write here X1. Now all Zj minus Cj are not greater than equals to 0. Therefore our solution is not optimal. Therefore we find pivot element, leaving variable, entering variable. Now we convert these pivot element as 1 by using the row operations. How we convert it is 1? If we choose the operation, which operation we choose? If we divide 6 for this row, we get it is 1. Okay, therefore first we change this pivot element or pivot row, then we solve the other operations. First we write here our first is S1 is as it is, S2 is changes by X1. Therefore here write we S1, here we write X1. Now write the coefficient of S1 is 0 and coefficient of X1 is 5 in objective function. Now we change this row. Okay, now what is it? Row become divided by 6, 6 by 6 1, 2 by 6 1 by 3, 0 by 6 0, 1 by 6 1 by 6, and 24 by 6 it is 4. Therefore our elements are 1, 2 by 6 means 1 by 3, 0 by 6 means 0, 1 by 6 means 1 by 6, and 24 by 6 means 4. Okay, therefore we changes our second row. Now become this row is 0. Now first row is changes. How it is changes? We make this 3 as a 0. Now we take a rough page and then we take the operations. Okay, how it is changed? Our second operation is R1 minus R2, new R2. R1 minus new R2. Write new here in bracket. Therefore, these two operations are given. First operation is 1 by 6 R2 and the second operation is R1 minus 3 times R2. R2 is new R2. Okay. R1 minus 3 here. Here we become 0. Therefore, R1 minus 3 times because this element become 1. R1 minus 3 R2. Okay. In that way we perform the operation. Then first write all R1. What is the R1? Roughly 3, 5, 1, 0 and 15. Don't write the ratio. Only terms into constant. Minus 3 times. Minus 3 times new R2. Write here minus 3, minus 3, minus 3, minus 3. And then write our new R2. Our new R2 is 1, 1 by 3, 0, 1 by 6, 4. In that way our calculation is fast. 3, 3 into 1, 3, 3 minus 1, 3, 0. 3, 3 cancel, 5 minus 1, 4. 3 into 0, 0, 1 minus 0, 1. 0 minus 3 ones are 3, 3 3s are 6 minus 1 half. Here is a multiplication. Therefore, this becomes 3 ones are 3 and 3 ones are 2. If here is minus, then no need for any operations. Okay. Then 15 minus 3 into 4. 4 into 3, 12. 15 minus 12, 3. Therefore, our first row is 0, 4, 1, minus 1 half and 3. Okay. In that way our calculation become fast. Okay. Now again calculate Zj minus Cj. 0 into 0, 0. 5 into 1, 5. 5 minus 5, 0. Okay. 0 into 4, 4. 5 into 1 by 3, it is 5 by 3. Minus 3. 5 by 3 minus 3. 3 3s are 9. It is minus 4 by 3. 3 3s are 9. Take denominator same. 3 3s are 9. 9. 5 minus 9 upon 3 means minus 4 upon 3. Here your is minus 4 upon 3. Okay. 0 into 1, 0. 5 into 0, 0. 0 minus 0, 0. 0 into minus 1 by 2, 0. 5 into 1 by 6, 5 by 6. 5 by 6 minus 0, it is 5 by 6. Here again all Zj minus Cj not greater than equals to 0. Therefore, solution is not optimal. Therefore, we write again we select entering element, leaving here element or pivot and pivot element. Therefore, we write here. Okay. Now, which we select the entering row or pivot row or pivot column? First we select pivot column. The most negative number in Zj minus Cj. Here minus 4 by 3 is a most negative number. Okay. Therefore, we select this as a pivot column. Therefore, again we find the ratio. How we calculate the ratio? Divide constant by the elements of pivot column. The element is 3. 3 divide 4. 3 upon 4. 4 upon 1 by 3. Means here 4 upon 1 by 3. It becomes 4 into 3 by 1. That is 12. Therefore, we select minimum element as a pivot row, which is a minimum element 3 by 4. It is 0 point something. Okay. It is pivot row. Therefore, our pivot element is 4. Now we want to become this element as 1. That is leading coefficient. Therefore, we perform operation 1 by 4 R1. Okay. First we changes this, which is pivot row S1. Okay. And which is first row is a pivot row. Therefore, S1 changes by X2. First we write the changing element that is x2, its variable is 3 in our objective function. Then we convert this first row, first element or pivot element as a 1. Therefore, we divide all the corresponding element of row by 1 by 4. First divide 0 by 4, it is 0. 4 by 4, it is 1. 1 upon 4, it is 1 upon 4. Minus 1 upon 2 upon 4. That is minus 1 upon 8. How it is become? Minus 1 upon 2 upon 4. Then it 4 becomes 1 upon 4. Then it is become minus 1 upon 8. Then 3, it becomes 3 upon 4. Okay. First row is completed. Now change in second row. It is x1. It is 5. Now we want this 1 by 3 as it is equals to 0. How it will become? It will become as R2 minus 1 by 3 times R1. That is new R1, because of new R1's element is 1. Therefore, R2 is 1 by 3. 1 by 3 minus 1 by 3 into 1, it becomes 0. Only we write here, or we select this operation by considering these two elements, and then we apply this operation in all the second row. Okay. Then first write all the old elements of R2. What is that element? 1, then 1 by 3, then 0, then 1 by 6, and then 4. Minus 1 by 3, minus 1 by 3, minus 1 by 3, minus 1 by 3 times, 1 by 3 times, minus 1 by 3 times new R1. Now write the new R1. 0, 1, 1 by 4, minus 1 by 8, and 3 upon 4. Now 1 by 3 into 0, 0. 1 minus 1, 1. 1 minus 0, 1. Okay. 1 by 3 into 0, 0. 1 minus 0, 1. Now 1 by 3 minus 1 by 3, 0. Now 0 minus 1 by 3 into 1 by 4. It will become 1 by 12. 4 threes are 12. It equals to 1 by 6 minus plus 1 by 24. Now first we want to changes the denominator as the same. 6 fours are 24. That is 4 plus 1 upon 24. That is 5 upon 24. Okay. 3 cancel. 4 minus 1 by 4. 4 fours are 16 minus 1 by 4. That is 15 by 4. Therefore our second row is 1, 0, minus 1 by 12, 5 by 24, and 15 by 4. Okay. In that way. Therefore our calculations are correct. Okay. Now we find Zj minus Cj. 3 into 0, 0, plus 5 into 1, 5. 5 minus 5, 0. 3 into 1, 3. 5 into 0, 0. 3 plus 0, 3. 3 minus 3, 0. 3 into 1 by 4, 3 by 4. Okay. 3 into 1 by 4, 3 by 4. 5 into minus 1 by 12, minus 5 by 12. Again 3 want to same as denominator. Then 3 3s are 9. That is 9 minus 5 upon 12. It becomes 4 upon 12. 1 upon 3. It becomes 1 upon 3. Again 3 into minus 1 by 8, minus 3 by 8, plus 5 into 5 by 24. 5 into 5 by 24. Okay. Minus 3 plus 25 upon 24 here upon 8. want to become same, minus 9 plus 25 upon 25. 25 minus 9, it is 14 upon 25. It is right? No, 16, sorry. 16 upon 24. Then 8 3 is 8 2 is 16, 8 3 is 24. It becomes 2 by 3. Okay, therefore 2 by 3 minus 0, it is 0. Okay, again we see 3 into 0, 0. 5 into 1, 5. 5 minus 5, 0. 3 into 1, 3. 5 into 0, 0. 3 plus 0, 3. 3 minus 3, 0. Again 3 into 1 by 4 plus 5 into minus 1 by 12. It becomes 1 by 3. Minus 0, it becomes 1 by 3. 3 into minus 1 by 8. 5 into 5 by 24. Add these two elements and then subtract the 0. It becomes 2 by 3. Therefore, here all zj minus cj are greater than or equals to 0. Therefore, our solution is optimal here. All zj minus cj are greater than or equals to 0. Therefore, our solution is optimal. Therefore, we want to write our z max. How to calculate? With x1. Write the value of x1. x1 equal to, and write the value of x2. x2 equals to, x1 equals to 15 by 4 and x2 equals to, write the value of constant. It is 3 by 4. Now we want to find z max equals to, in z max we give our original problem. Maximize z equals to 5x1 plus 3x2. Then we put the values 5 into 15 by 4 plus 3 into 3 by 4. 15 into 5, 75 upon 4. 3 3 is 9 upon 4. 75 plus 9 becomes 84 upon 4. 4 2 is 8. 4 1 is 4. 21. This is our z max. This is our final value of our simplex method example. Then how can write the final answer? Z max equals to 21 with x1 equals to 15 by 4 and x2 equals to 3 by 4. This is your final answer. Okay, if your answer is in last table, if here is s1 s2, then we write here 0 into s1 plus 0 into s2. It does not affect our maximized solution. Okay, thank you.